Hello everyone. In this video, we will learn about Python comparison operators. These are the one of the most widely used operators in any programming language. So let us see what are comparison operators. Comparison operators compare two values or variables and return a Boolean result. These are the operators we have and the operation performed by the operator and the example. Okay, so let us look at these in coding itself. First one is equal to. Let me take two variables, A storing value 5 and B storing value 6. Now let me use the operator in the print statement itself. Print A equals B. Okay, so let me run this code. You can see that since the value holded by A, which is 5, not equal to the value with the B, that is 6, we are getting a result as false, which is Boolean result. Okay, now let us go with the next one. Print of A not equal to B. Okay, so it is true because 5 is not equal to 6. Now next condition, print A greater than B. So whether it is greater than B? No, that's why we are getting false. Similarly, we can have for print A greater than or equal to B. So this is also false because equals condition is also not satisfying. If I change this value to say 5, okay, and now if I execute, you can see it is true. Okay, so let me go with the earlier value itself. So now less than, we print A less than B, actually which is true, and the last one, print A less than or equal to B. So obviously 5 is less than or equal to 6. I hope it's clear. Okay. One important point to note in Python comparison operators is these operators are widely used in program control structures. Now let us move on to the next type of operators, that is Python logical operators. So logical operators are used to check whether an expression is true or false, and they are again used in decision making. So the first logical operator what we have is AND. The operation it performs is A and B. It evaluates to true only if both the operands are evaluated to true. The next operator is OR. Operation is A or B. It is evaluated to true if at least one of the operand is evaluated to true. That is, either A is true or B is true, the result will be true. Here both should be true, A and B should be true so as to get the result true. Similarly, the next operator is NOT. Operation is not A. It will result true if the operand is false. Let us code and check the logical operators now. AND operator. So this is the keyword, right? I hope you remember. B is false. So Boolean values we are assigning true and false. Now let me print A and B. Okay. So it's false. Okay. Now again I will change this to true. So it is true. If I change A also false and B also false, now since both are false, the result is false according to the definition. OR operator. For this, let me take A is equal to true, B is equal to false, print A or since one of the operator is true, the result is true. Let me check another example here. Both the operands are true, the result is true. Now let us check the final one. So both are false, that's why the result is false. Okay. And the last logical operator we have is not operator. A is equal to say true. Okay. Let us print not of A. So the result is false. Similarly, if I put A is equal to false, not of A will be true. Okay. That's all about the logical operators which are used in decision making. Now let us move on to the next type of operators, that is bitwise operators. Bitwise operators act on binary digit equivalent of operands, that's why they are called as bitwise operators. Bitwise AND, bitwise OR, bitwise NOT, bitwise XOR, bitwise right shift and bitwise left shift. So as you can see, the binary equivalent of X, that is 10, and Y, that is 4, is given here, and the operation which is performed as bitwise AND, bitwise OR, bitwise NOT, which is a unary operator actually, then bitwise XOR and right shift, left shift. The result of these operations is given. Now let us check the same in the code. Okay. So when it comes to bitwise AND, the truth table of bitwise AND is here. As you can see, the result is 1 only when A and B both are 1 or both are true. Similarly, for OR, we have the result is equal to 1 if at least one operand is equal to 1. Okay. XOR, for XOR, when one of the operand is 1, the result is 1. If both are 0 or both are 1, the result is 0. Okay. For NOT, if input is 0, output will be 1. Okay. With this basic, let us code. Let me take X is equal to 10 as in the example, Y is equal to 4. And now let us print X and Y. Okay. Result is 0 because no bits are matching here. Okay. Now let us look at bitwise OR. Print X or Y. So it is 14. Okay. As you can see the result. Similarly, bitwise NOT. Negation of X. Actually, here the operation performed is X is equal to minus X minus 1. Okay. So answer of 10 will be minus of 10 minus 1, which is minus 11. So let us check the same. Yes, we have got. Let me change x value is equal to 20. The result will be minus 20, minus 21. Okay. I hope that's clear. Now let us move on to the bitwise XOR. Let me change the x value as 10 only as earlier. Now print x XOR y. So it is 14. So we know that x is represented as 10. Okay. The binary equivalent is 10, 10 in 4 bits. But in 8-bit representation, this is the representation. Now when we perform right shift on x, what will happen is these bits will be shifted towards right. Okay, so let me show it here. So the bits will be shifted like 1 bit, 2 bit. Now I have to write 0 0 0 0 1 0. Okay, and the MSBs will be added with 0 0. So when I get it back to the position and align, you can see this is 2. Right shift by 2 will give us result as a binary 2. Correct? It is right shift by 2 positions, right? That's why I'm getting 2. If it is only one position, the value would have been different. Now let us check this result first. Okay. X right shift by 2 positions. Result is 2. Now if I shift it by only one position, the result is 5. Why? 0, 0, 0, 0, 0, 1, 0, 1. So this one bit is shifted towards right. That's why I am getting the 8-bit equivalent as this one. 1, 0, 1. 1, 0, 1 is 5. I hope that is clear. Now coming to the bitwise left shift, print x left shift by 1 will check first. It is 20. Why it is 20? Because we had a binary equivalent of 10 as 0 0 0 0 1 0 1 0. Now when I do a left shift, what will happen? We will get this bit erased and there will be bit added here. So this is equal to 4 and this is 8. This is 16. 16 plus 4 is 20. Similarly, if I shift by 2, again I need to shift 1 bit and I will add 0 here at the tail. So because of this, this will be say 8 and this is 16. This is 32. 32 plus 8 is 40. So let us check that. You can see it is 40. I hope bitwise operators are clear. As I already told, we have another kind of operators, that is Python special operators. These operators will discuss once we have completed with collections in Python. Do subscribe to my channel and share with your friends. Thank you.